Hi, my name is Leung Ka Yao. I'm going to present for my final year project. So I am a year 4 student. I'm taking the courses of Civil Engineering Technology Construction. So my title for my final year project is Group Shed Design Affecting Pedestrian-level Wind Speed. My supervisor is Dr. Muhammad Hafizah bin Hanifah. First of all, I want to appreciate to my supervisor, Dr. Hafizah, because he taught me a lot of things about this pedestrian-level wind speed. For extract, the outdoor spaces significantly contribute to provide outdoor activities such as walking, cycling, and exercise as a daily routine. However, this activity we cannot access it in nowadays at the outside area due to this urban heat island island effect. To date, the private study have shows that the effect of group shed design to improve the pedestrian-level wind speed. Thus, this study aims to evaluate the impact of a group shed design of building towards the pedestrian-level wind speed by using the CFD simulations. So, the robustness of the simulation will be determined by adopting the validation process. So, for this study, it shows that the mean wind speed around multiple building with the wedge roof design is the higher ratio at the pedestrian-level mean wind speed around the educational building at campus UTHM Pagoh. It can be concluded that one of more significant finding to emerge from this study is that the wedge roof design shows the optimum performance towards the pedestrian-level mean wind speed, and followed by the flat roof, gable roof, and welder roof. In addition, the result shows that this roof design has significantly influenced the mean wind speed at the pedestrian level. For introduction, nowadays, the rapid urbanization and climate change have caused the urban heat island effect continuous current in the urban area. So this UHI is an atmosphere phenomenon where the temperature at urban area is higher as compared to the air temperature at the rural areas. So there are a lot of strategy we can use to modify the building in order to improve the pedestrian-level wind speed. So among the different factors related to the design of building, roof shed is a well-known parameter. We can use it to design for the building because it can significantly influence the flow of wind around the building. So therefore, it is necessary to design an optimal roof shed with the purpose to improve the pedestrian-level wind speed. So for objective, first is to identify the roof shed design affecting to pedestrian-level wind speed. Second is to investigate the effect of the roof shed design towards the pedestrian-level wind speed on the multiple building by using the CFD simulation software. Third, I want to establish the optimum roof shed design towards the pedestrian-level wind speed performance. For literature review, Overall, the primary research shows that the roof shape design can significantly influence the flow of wind condition around the building. Only a few research have mentioned for the pedestrian-level mean wind speed. So in this research, it shows that flat roof recording the highest ranking for the number of research, followed by the gable roof, water roof, and wedge roof. Moreover, the private research, they are more focused on the pressure or the temperature around building. So it will be interested if they are more focused on the pedestrian-level wind speed around the building by using the different roof shape design. For methodology, as you can see in the poster, the methodology for chart. So first is the site selection. So I'm select the Pagoh, Campus Pagoh as a site selection because due to its the packing density can be represent the urban areas, the building urban areas. So by using the AutoCAD, we design the model and transfer it to the NC Design Modular. So you can see the picture, the 3D model in NC Design Modular. And then for simulation setup, so we setting for it the boundary condition, and also the grid resolution for this model. And finally we get the result and we compare it with the data from the AIJ guideline. So the picture shows that in below the illustration of data extraction location. So this is for the result. So the next is result and discussion. So as you can see in the picture, the graph shows that the MVR value of a wedge roof is the highest as compared to the other cases. This shows that the wedge roof is there is more available of wind is at the pedestrian level around the building with a wedge roof. So according to the abstract, when I say that wedge roof is the highest because when the wind flow through the roof, so it will separate after across the sharp leading edge at the rooftop. So this edge will cause the wind cross and the pressure become lower and cause the formation of a vortex. So the presence of a buoyance increase the turbulent kinetic energy, so the wind can directly vertical float to the ground. So for flat roof, it shows the second higher ranking as compared to other cases. So a possible explanation for this might be that the wind flow through the rooftop, the air circulation occur near the roof edge and vortex form at the wind side of the building. Thus, there is still more wind flow to the ground. But it is less than the wedge roof, the wing speed, average wing speed. So for the gable roof, the performance of gable roof shows significantly same with flat roof because it's just only significant. So we can say that the gable is more same with a flat roof because when we across the ridge of a gable roof, so it's same result with the wedge roof, which it can improve the thermal comfort and pedestrian level. The water roof shows the worst performance toward the pedestrian level mean wind speed around the building because as the wind across the building and also from the top of the building, the floor does not spread out from the wet roof and it just float at the above area of a roof surface. So it does not, the wind cannot float, go through the pedestrian level above the ground. For conclusion, it has been conclusively shown that the frequency for the number of flat roof recorded the highest ranking, followed by gable roof, water roof, and wedge roof. So basically this study shows that the mean wind speed around the multiple building with wedge roof design is the higher ratio at the pedestrian level mean wind speed around the educational building UTHM Campus Pagoh. So it can be concluded that significant finding to emerge from this study is a wedge roof show the optimum performance, followed by a flat roof, gable roof, and water roof towards pedestrian level mean wind speed around building. So the result proved that roof design has significantly influenced the mean wind speed at the pedestrian level. So below is the reference. Anyone can see that in the poster. Last but not least, it is recommended the further research should focus on the different roof shape design around the multiple building with a different heights, because for this study is the height of a building is maintained, is constant. So the further study focus on different height of building will be more interested. Thank you very much.